square. So that is Fisher information for one observation. So In of theta is nothing but n into I of theta, which is n by sigma square, Fisher information for n IID variables. So variance of theta hat, if we find, that is greater than or equal to 1 by this In of theta, which means it is equal to sigma square by n. So that means the Cramér-Rao lower bound is theta square by n, and even if we consider our variance of x bar, that is also sigma square by n. So therefore the Cramér-Rao, the variance of the sample mean coincides with the Cramér-Rao lower bound in case of the normal model. Now in case of the Bernoulli model, so we know that xi follows Bernoulli theta, 0 less than theta less than 1. Theta is unknown. So that means like probability of xi is equals to 1 is theta, and probability of xi is equals to 0 is nothing but 1 minus theta. So expectation of xi is equals to theta. So that means expectation of x bar is nothing but 1 by n into summation I is equals to 1 to n expectation of xi, which is nothing but theta. So therefore x bar is unbiased for theta. Now variance of x bar is nothing but 1 by n square into summation variance of xi, which is 1 by n square into n theta into 1 minus theta, which is theta into 1 minus theta by n. So the PMF for one observation, if we write, so that is fx of theta, which is theta to the power of x into 1 minus theta whole to the power 1 minus x, and x belongs to the 0 to 1. So that means the log likelihood L theta of x is nothing but x log theta plus 1 minus x into log 1 minus theta. So the score function is nothing but the first derivative. So dou by dou theta L theta of x. So that is nothing but x by theta minus 1 minus x by 1 minus theta, which is x minus theta by theta into 1 minus theta. So expectation of this s of theta of x is equals to 0 because expectation of x is nothing but theta. So therefore the Fisher information is I of theta is expectation of s of x whole square, which is nothing but expectation of x minus theta whole square by theta square into 1 minus theta whole square, which is variance of x by theta square into 1 minus theta whole square, which is 1 by theta into 1 minus theta. So the Fisher information for n observations is n into I of theta, which is n by theta into 1 minus theta. So that means variance of theta hat is greater than or equal to 1 by n of theta. So that is equals to theta into 1 minus theta by n. And even the variance of x bar, we got it as theta into 1 minus theta by n. So therefore x bar attains Cramér-Rao lower bound. So therefore it is efficient, and so basically both are coinciding. So both 1 and 2 is correct.